Okay, our notes today are on pages 17 and 18, and the title for your table of contents is Polynomial Division. So let's flip to page 17, and I actually want you to title this page Synthetic Division. So I know we've talked about lots of different methods of dividing, but the method I want you to put into your notes is the synthetic division. So if we are dividing, for example, the polynomial x cubed plus 2x squared plus 4x plus 6 by x minus 2, here's how we would do this division problem using synthetic division. So we're going to go ahead and draw in our division box, and I'm going to fill in a 2 out in front. Remember that that 2 comes from the opposite of our divisor. So we were dividing by x minus 2, so that's a negative 2 there. Over here we're going to use a positive 2. So make yourself a thought bubble just to remind yourself that is the opposite of our divisor. Okay, then we're going to go ahead and fill in our coefficients from our dividend, which is our polynomial we're dividing. Remember that there is an invisible 1 in front of that x cubed, so our coefficients are 1, 2, 4, and 6. And let's make sure we're all clear on where those are coming from. So highlight the 1s in the same color, and so this 2 came from our coefficient for our x squared, and we also have our 4 came from the x, and last but not least, our 6 came from the constant term. So we're just going to make that one purple because I ran out of highlighter colors today. Okay, so remember that the very first thing we did was we just brought down that 1. We're not going to change it at all, it just comes down. And then I'm going to draw this loopy arrow to remind myself that to get this number I am going to multiply. So the 2 times the 1 gives us a 2. And then to get this number we're going to add. So go ahead and fill in that there we're adding 2 plus 2 is going to give us that 4. We have to multiply again. 2 times 4 gives us 8. And add again. 8 plus 4 gives us 12. We have one last time that we need to multiply, so 2 times the 12 is 24. And add last time, 24 plus 6 gives us 30. All right, now that we have all of our coefficients found, we need to write this as our final answer. So we're going to fill in x squared, 1x squared, plus 4 is our x term, plus 12. And this 30 at the end, that's our remainder. So we have a remainder of 30 on this problem. Okay, so I would like you to find, from one of the problems we've done in class or one of the problems you did in your homework assignment, another example that you're going to complete in your notes. So you're going to fill that out on your own. All right, let's go to page 18. And on page 18, we're going to fill in the remainder theorem. So our remainder theorem says, when dividing a polynomial, by x minus some number a. In this problem that we just did, our a was 2. We were dividing by x minus 2. But if we don't know that value, we're going to use a to stand in for that value. You can find the remainder by evaluating f of a. Okay. So, for example, if f of x equals x cubed plus 2x squared plus 4x plus 6, and we want to divide by x minus 2, then we could find the remainder. So to find the remainder, by evaluating f of 2. And I'm going to highlight again here in my orange to remind myself that, again, this is the opposite of what we're dividing by. We were dividing by -2, and here we're going to use a +2. So we've got to use the opposite of that divisor. Okay, so if we're going to find f of 2, everywhere there's an x, we're going to plug in 2. So it's going to be 2 cubed plus 2 times 2 squared plus 4 times 2 plus 6. And we could go ahead by hand and figure out what each of those is. I would recommend that you don't. Plug that into your calculator and it's going to tell you that that answer is 30. So we know that we have a remainder of 30. Okay, so we got a remainder of 30, which, hey, looking back at our problem, when we divided this, we knew that our remainder was 30. Okay, so the question is, why do we care? Well, the whole reason we are bothering dividing polynomials is so that we can find the factors of polynomials. And so we want the remainder to be 0, so we know that we found a factor. So we can quickly tell if we found a factor if we know the remainder is 0. Okay. All right, that will be the end of your notes for today.